So we have our vertex form. We still have A, but we don't really have B and C anymore. We have H and K. Now the A part, that still tells us if it goes up or down. If A is greater than 0, it goes up. If A is less than 0, it goes down. Okay, that hasn't changed. It also still tells us if it's wide or narrow. So it's wider if A is a fraction between 0 and 1. It gets more narrow if A is bigger than 1. Okay, so this is exactly the same as standard form. Nothing different. Okay, we're going to go to H next. H tells us the x value of the vertex. It also tells us what we call the axis of symmetry, which we abbreviate AOS. Do you guys know what symmetry is? When they say something is symmetrical. The same on both sides. So just like how you guys noticed on your tables how one half of the table looked exactly the same, that's symmetry. The axis of symmetry is that line where you could put that mirror and reflect it over. So the axis of symmetry is going to always be the equation x equals whatever h is. Next we have K. K tells us the y value of the vertex. It also tells us the value of the minimum or maximum. It also tells us our range. Y is going to either be greater than or equal to or less than or equal to whatever K is. So all of this information can be found just by looking at the equation. Not by graphing anything, just by looking at the equation. And that's one of the things that we're going to have to do. So if you're someone who that uses flashcards to memorize these things, it might be helpful to make flashcards so that you remember what vertex form tells you and what each part is. So A is the same in both forms. It's the same in standard and vertex. But H and K are only applying to vertex form. Okay? And there is a third form we're going to learn. So we have 3 forms total. Standard, vertex, and then factored. We'll get to factored later. So what we're going to do right now is just practice identifying A, H, and K. Okay, we're just going to identify. So identify A, H, K, and the vertex. That's the abbreviation, capital AOS. That's the abbreviation we use for axis of symmetry. So when you see it on your homework, that's what it means. Because we don't always like to write out that whole statement every time. Okay, so let's start with A. A is 2, and what does that tell us about our graph if it's 2?
It goes up.
Goes up. And then what else? Is it going to be wide, narrow, or normal?
Narrow.
It's going to be more narrow because 2 is bigger than 1. Okay, what about H? It's actually, so this is something I hadn't mentioned. It's always the opposite. So the negative, if we look back up to vertex form, the negative is part of the formula. So when we pull it out, it has to go opposite of whatever it is. So if this is a -5, that means it comes out as +5. And you only do that on the x, not the y. Okay? So if h is 5, then what is our axis of symmetry? X equals 5. Okay, that's what h tells you. That's the equation x equals h for the axis of symmetry. Next up is k. 3, good. And then this helps tell us our range. So our range, is that going to be a greater than or less than? So if our graph is going up, it's going to be greater than whatever that y value is, or that k value. We also know that the value of our minimum or maximum is also going to be 3. In this case, it's going to be a minimum. And then lastly, what is the vertex? So what's the x value of the vertex? Which letter is the x value of the vertex? H is, so 5. And then what's the y value? What's the y value of the vertex? 3. So h and k are what tell you your vertex. The exponent doesn't do anything right now because right now we're just reading information from the equation. Now, when we go to actually graph it, we will have to plug in some numbers and evaluate or simplify, kind of like the table of values. It'll play a role there, but right now it's just kind of hanging out there. Okay, let's try another one where we just identify all the different parts. I was going to give you guys time to write it down. Some people are still writing it down. Okay, so what is A? And what does it tell us? Is it going to go? It's going to go down. Is it wide or narrow? It's narrow. Okay? Because we're not looking, when we consider wide or narrow, do you see how there's no negatives here? We're not looking at the negative, we're looking at the number. Just the 4, not the negative. The 4 is greater than 1, so it's going to be more narrow. In order to go wide, it has to be a fraction. That's between 0 and 1. Okay? So we don't, when we look at the -4, the negative tells us one thing, the 4 tells us another. So you kind of have to separate them in terms of identifying those two things. Okay, what's H? 2. So then what is our axis of symmetry?
2.
X equals 2. We want to get in the habit of writing it as the equation x equals 2. And then what's K? 8. So our range, we're going down, so it's going to be y is less than 8. And then the value of the maximum will also equal 8.
I have a question.
Yes.
How do you know it's the maximum?
We'll get into that in a moment. No one asked that question on the homework, otherwise I would just show you, but we'll talk about it when we actually graph one.
I don't get the range of less than 8.
Okay, so we said our graph goes down, right? So if we think about what that looks like, it means it's going like this. That means I'm going to have a highest point and all the y values are going to be smaller than that. So I know that that highest point is going to be at 8. So that means the rest of them have to be smaller than 8. Just like over here when this one goes up, so that means it's going to be my lowest point or my minimum. Here it's a maximum. So it's all the y's that are bigger than whatever that y value is. So whenever it goes up, this symbol is going to be a greater than. Whenever it goes down, your symbol is going to be a less than. Okay, what about the vertex? What would our vertex be? 2, 8. Okay, we're going to do another one. So on number 3, what does A equal? Reagan? 1.
Also, what if it's like x plus 1, not minus 1?
There's one like that we're going to do. That's number 4.
Okay.
Okay, so A is 1. So is that going to go up or down? Up because it's positive. Now is it narrow, wide, or normal? This is normal. When it's 1, that's your normal graph. Because if narrow is when it's bigger than 1. Wide is when it's between 0 and 1. When it's 1, we actually call that normal, because that's our parent graph. What's H? H is 1, so that means our axis of symmetry is x equals 1. What's K?
0?
0. There's nothing being added. So when there's nothing out here being added or subtracted, it's just 0. So that means for our range, are we going up or down? So that means we're going to be greater than 0. And again, the value of the maximum or minimum, in this case it'll be a, so if we're going up, are we going to have a low point or a high point? Low, so this is going to be a minimum at y equals 0. And then lastly, what's the vertex? 1, 0. Okay, number 4. So this one's going to answer your question, Reagan. What's A? -1. So we go up or down? Down. Wide, narrow, or normal? Normal. Whoops, not B, H. What does H equal? Remember, it goes opposite. So Reagan, if it's positive, it's going to come out as -3. So that means our axis of symmetry is going to be x equals -3. K, -4. So that means our range is going to be y. It's going down, so less than -4. And again, it's going down, so are we going to have a high point or a low point? We're going to have a high point, or max. So we'll have our max value at -4. And then last bit, vertex. What's our vertex? -3, -4. Okay, the first part of your homework is just finding this information and being able to determine narrow, wide, normal, axis of symmetry, your range, your vertex, and all that. But you're also going to have to then put all this on a graph after you figure it out. Okay? So before we go on to putting this now on a graph, are there any questions about just how we find each piece of information from the equation or what it tells us? Yeah. The domain is always all real numbers. That's going to be true throughout the whole unit. So that's kind of like the gimme question. Whenever you see it, just put all real numbers. All right, so let's graph one. We're actually going to graph a couple, but we'll start with one of them. Now, before we actually graph it, we're going to find the same information we just found. So what is A? 1. Should it go up or down? Up. And is it going to be wide, narrow, or normal? Normal. Okay. What is our H value? 4. That means our axis of symmetry is going to be x equals 4. K is 1. So I know that my range is going to be y. It's going up, so greater than 1. And the value of my minimum will also be 1. I also know that my vertex is going to be 4, 1. So I'm going to use all this information to help us put it on a graph. So how can I use this to help me figure out how to sketch my quadrants? Am I going to have negatives? How do you know we're not going to have negatives? Well, right in here it says we know our y's are going to be bigger than 1. So I know I'm not going to have any negative y's. So for that matter, I don't need to do much in terms of space on the y's. So when you're sketching your own graphs, you can use this information to help you figure out, do you need to draw all 4 quadrants, or can you like do one more than the other? All right, we have 1, 2, 3, 4, 5. I'm going to go a little more than, I'm going to go like 6. I'm going to make sure I have room on my X to go a little further than my vertex and go a little higher than my vertex. Now in your homework you'll actually have graphs, so you won't have to sketch your own right now. But okay, first thing we're going to do is graph our vertex. So 4, 1. Then I'm going to graph my axis of symmetry. So how do you graph the line x equals 4? What kind of line is that? Anyone remember from last year? Not horizontal. Vertical. Okay. It's going to be the vertical line that goes through the vertex. That's your axis of symmetry. We're going to use that to help us not have to make a table of values. Okay, that's one of the things we like about vertex form, is by using this line, I know that everything on this half has to reflect over to the other side. We're going to use that reflection so we don't have to do as much work, as much algebra. Okay, so from here, we've graphed pretty much everything we can from our given information. We need at least one more point. So you can pick a number somewhere to the right or somewhere to the left of 4. So on one side of your axis of symmetry. I'm going to go ahead and pick 2. And I'm going to plug 2 into my equation for x. So I'll have y equals 2 minus 4 squared plus 1. Now order of operations, parentheses, 2 minus 4 is negative 2. Exponents, negative 2 squared is 4. We don't have any multiply or divide, so we go ahead and add and get 5. So that means when x is 2, y is going to be 5. So now I need to reflect that point to the other side. So 2 has a distance of 2 spots from my axis. So if I go 2 spots this way, I should be back up at 5. So using that symmetry, you only ever have to plug in one value. Okay, so that's finding the information and putting it on the graph all in one. Yeah. Okay, so do you remember how symmetry works? Okay, the distances have to be the same. So I plugged in 2 as my x. That was 2 spots from my axis. So I'm going to go 2 spots, and at 2 spots over, it should be at the same height. So if you want, you can do it from here. Like this has a distance of 2, so I have to go 2 this way, and it'll reflect over to the same spot. You just reflect it. That way you're only really finding one point, because you already got your vertex from the equation. You're only doing one algebra point instead of 5 or 6 like you were last night. Okay, this is what you're doing on the first 6 problems, what we just did here. So you might not find everything that we found here. I might have done a little more, but you're gonna have to identify the axis of symmetry, determine if it's normal, wide, or narrow, state the value of the minimum. So in this case, so Chloe, kind of going back to you, is that a low point or a high point on the parabola?
That's a low point.
So it's a minimum. And the value of that is 1, and then our vertex is 4, 1. Now on 2 problems, I think it's just on 2. No, on 4 problems, you're going to have to also talk about increasing and decreasing. So when you hear the word increasing, what do you think? Going up. What do you think about decreasing?
Down.
Going down. So what we're looking at is when is our graph going down and when is it going up? How do you read? So that's exactly how we read a graph, from left to right. So on this graph, if we read it from left to right, am I going down or up right now? So that means we would say that it's decreasing when x is smaller than 4. Because all these numbers over here are smaller than 4. But what happens when we get to 4? What do we start doing? We start going up. So we increase, or we're increasing when it's greater than 4. So you're going to have 4 questions where it's going to ask you where are you increasing or decreasing. This value here is going to be the x value of your vertex. And you just have to determine, are you increasing or decreasing when you're smaller than that or when you're larger than that? Yeah.
Can you choose any number when doing the graph?
For this part?
Yeah.
Yeah, you can choose any one. I would suggest though you don't go more than like 2 in either direction, because it might go, your y value might end up off your graph.
So there's a lot of answers.
There could be, yeah. Most people, I would say, do either 1 away or 2 away. If you like to go to the y-intercept, you might end up with a really high point. That's why I would say don't go too far from your axis, but you could do two or 3. I really wouldn't go more than 3 though, because that's usually off. Okay. Yeah, we're gonna do one more graphing all together. This is number 6. Yeah. Y equals x minus 1 squared minus 5. Okay, what's our A? 1. So what else does that tell us? It's up because it's positive. Wide, narrow, or normal? Normal. What about H? H is 1. So that tells us that our axis of symmetry is x equals 1. K is -5. So my range is going to be y. It's going up, so greater than -5. And our vertex, 1, -5. So do I have to do negatives on this one? Yep, because my vertex is negative. But I really don't have to go much lower than -5 because that's the lowest part of my range. So when I go to do my graph, I'll make sure I do -5. One, 2, 3, 4, 5. So we graph the vertex 1, -5. Then we graph our axis of symmetry, x equals 1. Then we find a point to plug in. So if our axis is here at 1, we just need to pick an x value either to the right or the left. 3. Okay, so if we plug in x equals 3, we'll have 3 minus 1 squared minus 5. So parentheses, that'll give us 2 squared. 2 squared is 4. 4 minus 5 is -1. So 3, -1. So how far away was 3 from our axis? 2 spots. So we got to go 2 spots in the other direction and we'll get the other point. Connect the dots and you have your parabola. And if you're at the questions that ask about increasing or decreasing, where are we increasing? So where do we go up?
When x is greater than 1.
When x is bigger than 1. And where are we going down? When x is less than 1.
Are you going to ever have an axis of symmetry going horizontally?
Yes, but not in this class. You'll do horizontal parabolas next year. Right now we're sticking vertical. Okay. Yeah.
How many times did you go over to the?
2. Okay, so Tyler suggested, or who suggested 3? Was it you? Yeah, so that, for this distance here, that's 1, 2. So 1, 2.
I thought you should go
It's measured from the axis of symmetry, not 0. Okay, any other questions that you guys have at this point? We're doing more of this tomorrow, so the whole goal is that by like by the end of the class Thursday, you guys will have a good grasp about graphing. Okay, if you're still a little fuzzy right now, that's okay. We're only on day 2. Okay, by the end of block day, it should be a lot clearer. Okay.